So good morning. My name is Michael, and maybe you're wondering why I'm presenting here, because this topic has been submitted by our dear friend Andy Barnes. So I'm stepping in for him. He's not available this week. And if this is running good, I'm taking all the credit, but he has prepared everything. So we have a lot to share, so let's just dive into it. First, have a look at IoT success factors, and maybe we call them failure factors. And this is some kind of common sense in the industry that numbers are aligned like that, and it's also aligned with our view on this whole topic. That means, and this is really strange for me, so 70% of all IoT projects seem to fail somehow for different reasons, and the main obvious reason why they fail is due to financial reasons. So out of this 70%, half of the projects fail due to mainly ROI things, so return on invest. That means that people, maybe they invest into things like, I don't know, energy saving things. They have a number in their head, what they want to save, get as a save out of that. And they pay much more on the whole solution than they get in return of that. Failed. Then we have things like the partners you're working with, and this has different angles, right? So you can look at devices, your sensors, which may be not suitable for your use case, your whole solution. Maybe you have done a POC validation at a small scale, and then you need to add 10,000 more things, and everything crashes down because your solution is not scaling enough, or you cannot migrate to cloud or something like that. Then, of course, we have things like execution. Things can get really complex from time to time, and you add different things together. Programmers involved, all this type of stuff is getting complicated, and you need experience for that, and you get experience by making failures. So this happens by nature somehow. The next thing is networking, of course, and the good thing is, you see this tiny little red thing there? Only 5% of all the projects fail due to networking problems or failures. And all these things like reliability, stability, coverage, and these things, you know it, we can easily deal with that. So just proper planning ahead, not only for the requirements of today, but maybe for the requirements of tomorrow. Everything will be fine. It's not an issue if you're aware of that. So what's our perspective on popular IoT use cases? So at Ruckus, we have this little bubble where we live in. Of course, there are lots more of use cases, and even with us, there are a lot of more than these shown here. But this is the top list of things we are seeing on a day-by-day basis. And especially the first one, and I will talk about online DAX first, this is coming from hospitality, like hotels. This is coming from education. This is coming from MDU, so rent to live or senior care, something like that, where online logs are really key for good end-user experience or adding additional services, adding security. Like, imagine I leave this here on the floor. Some guys of the hacking pen test group steps by, grabs this card, go to the floor, and slide it on every door in the hotel. And at some point, they will get into my room and rob me, maybe. If they have online logs, that could be prohibited, because maybe it's possible to detect a pattern. Someone is trying to do that. You can trigger an alert, and then security is sent their way, and the bad guys are catched. Something like that. When we then transition to another hospitality use case, it's obviously staff safety buttons. So things like panic buttons. And this is mainly driven by or have been driven by the US regulations. So there is some kind of, I don't know, law that needs hotels from a certain size to provide member of staff with this kind of solutions to help them in emergency situations. They can call for help if they're threatened when they enter the room of the guests. And they are really required to do that in the US. Not sure about here, to be honest, in Europe. And obviously, this is not meant to spy the people. So it's not, data privacy is very important. It only should send the information who has a problem and where is the problem when you push the button. So that means you need high battery lifetime on these devices. And of course, there are different angles. You can do it via cellular, for example. But when you do that with a cellular radio, you need to add, I don't know, a battery which is such big, or you charge it every shift or every 24 hours. So BLE is quite a cool use case. With a hospitality-grade device, you can get battery lifetime of years when you're not threatened every day, hopefully. When you do that on a regular basis, so not only by pushing a button, you have things like location-based services. You can find assets. You can find things or people which are in need. You have the possibility to track if something leaves a certain area and it's not allowed to do it. You have the possibility to check if something is accessing a restricted area, of course. Yeah, you all know about that. Energy management is the next very important part, and Peter already calculated how much money we can save in just shutting down some of these power consumption things. And yeah, just use this hotel as a use case again. That means people are interested in how much time I spend in my room, maybe. If I use the heater, if I use the air conditioning, how long these devices are turned on. And then I can see trends. Maybe I can tune my environment for very efficient operation. And in most cases, when you do it right, this use case alone will pay for the whole project. Then, environmental management. So this is more about caring about the well-being of the building itself. Like in education, we have things like monitoring air quality, CO2 values, and so on. We can provide fresh heads for better learning experiences. We can open the windows somehow. We can turn on the ventilation. Also for COVID things, this is really, really helpful. But it's also about things like monitoring water temperature, because maybe you can then get rid of Legionella problems in your house, or you can detect water leakage or flooding events. So it's all about not about money, not so much, but yeah, adding value to people's life and their health at the very end. And then we have safety, and of course this integrates into other stuffs, like the card example from before. Yeah, so that means it would be very helpful to get some event correlation and video camera. There are video cameras in every floor, I think. Event correlation, so when something happens, when the card is used in a not appropriate way, I would like to have the video stream of that floor and of that person. Also, monitoring if people are coming from restricted areas or going into restricted areas, like in airports. This is very important to know about. And of course, it's about workplace monitoring. And nowadays, like where we not go to the office anymore, or not so often. How is the workspace utilized? Maybe can I connect this with energy management and then save a lot of money in cutting down costs there. So, and I think you can add a million other things, depending on the industry. So this is heavily focused on these three I've mentioned before, but yeah, it's just 30 minutes. Okay. When you plan such a solution, or any kind of solution, it's quite high level here, then you have to plan for the whole solution. And I've made up here four areas. And mainly, when people think about that, they talk about protocols and say, okay, I want to build a Zigbee network. and then they add their thoughts after that. And that's the wrong approach. You should be technology agnostic. That means you have a use case, you have a problem to solve. It doesn't matter which protocol you're using at the end. Of course, some use cases dictate some protocols because they are very suitable for that. But yeah, it really depends. More important than the actual protocol at the very end is the choosing of the vendors. So I'm talking about chipsets, I'm talking about these things. Make sure that they're available 5 years in the future, that they have that they are reliable, that we can get these devices at the end. Also, coverage, of course, is very important when we think about wireless IoT. And yeah, it just makes no sense to cover a golf course with a BLE thing, right? There are more proper protocols that cover long distances and are more suitable for outdoors or indoor environments, depending on the use case. Another thing is reliability, and that's really a key differentiator for industry-grade or use case-grade devices like for hospitality, for Industry 4.0, because there's a difference between something you can buy on AliExpress for a few cents or a real good device which has a battery life of, a few years. Also, being resilient to noise is very important because if things get going, you add more and more devices, you add maybe things to an industrial environment where machines are working all the time. This is getting very, very important. And also power and redundancy. That means it's always a trade-off, obviously. That means there's no sense in having a sensor which is meant to last 10 years, but therefore you have to plug it into the mains all the time. Yeah, that makes no sense. And also redundancy, make sure this is also working if something goes down, someone is plugging a cable, so that you prevent IoT dead zones. Diagnostics is also very important to consider because not all networks are equal, not all use cases are equal. And let's see, what about a sensor which is meant to send data once a year? How you make sure that it's operational, that it will send data in 50 weeks, and how you manage that the battery is not dead until then, and how you get insights in the healthiness of all of this. And then, of course, scalability. In most discussions we have, people want to do something with IoT. They mostly have no idea what they want to do, but it's fancy. You have to do it somehow. And then when it starts, it's get big in the very end. So it's a very big difference in using off-the-shelf hardware to do a POC with ULAMPs and so on. And there's nothing wrong with that because we have to demo this technology. It's suitable for certain use cases, but it's a difference if you add a door lock here with one AP, for example, and then scale out to a resort with 10,000 of devices. So we are speaking about devices all the time and sensors, but this is only a small part. Using or integrating into third-party solutions, like, I don't know, things like Samsung SmartThings, like solutions for location-based services and so on, is also a very big part of the solution, and that could be the part where it gets most complicated. And you have just to make sure that you choose the right partner, that they have an operation model that is suitable for your use cases, is cost-effective, that they can scale, that it's flexible. Maybe it's needed that you get some deployment on site. Maybe you use edge computing to get very little latency for certain critical operations. But maybe it's needed that you scale out into the cloud because you're getting bigger and bigger and bigger, and I don't want to have the servers on the site all the time. The next thing, of course, is that they can integrate in your overall solution. And relationships with these people are also very important, of course. Talking about hardware, software. This is quite interesting. Of course, you should be sure that these things are standard compatible, but from time to time, and more often, you will see they claim that they are compatible, but they're not. So that means sometimes you spend a whole lot of time finding the right device which is really working and doing what you want from them. Not only because there's a sticker on the front stating Zigbee, it's really compatible. It could be a pain somehow. That means these devices need to be able to integrate into a solution, that they have an integration strategy for that. Is this really helping to solve the problem? And that's really interesting to see that you have to get the end in mind and not start with, I want to build a Zigbee network and then add things without, and then losing track of what you want to achieve at the end. Of course, they need to be resilient. They have to work in the use cases you are looking for: outdoor, indoor, temperature ranges, battery lives, and so on. And most importantly, and that comes back to the very first failure point, everything has to be inclusive. That means when you have a bill of materials at the end, you should consider everything and make sure that there's no hidden cost, because there are likely hidden costs which you want to avoid. Speaking from the perspective end-to-end, just make sure you're including everything. That means not only planning for RF coverage, for access points, gateways, something like that. Consider every aspect of that thing. That means uplink connectivity, amount of traffic, latency requirements, cloud services, internet access, whatever it takes to make this work, take it into consideration. The next thing will be dashboarding, monitoring, management. This needs to be there because of, I've already mentioned that before. You need to know what's going on, and IoT is all about the data at the end. We don't care if this device is working like in this way or that way. People want to make use of the data, and this is where the benefit is. So having easy access into the data flow, passing information out of the data stream, and having a reporting engine in place that somehow is able to use their triggers and if then that conditions to send alerts, alarms, right into databases and so on, is really, really helpful to have a universal solution. And of course, also here, experienced partners are quite important. And we know someone. You can get to that for these questions. I need to hurry up a little bit, sorry. For the last big thing here is deployment. That means when you talk about deployment, it really quick comes to density of APs, gateways, where do you want to place them. It's like Wi-Fi design a little bit, but it's different. That means, maybe we talk about the use case, or I walk you through this hotel again. So imagine this hotel wants to add door locks to the Wi-Fi system, and Wi-Fi system is acting as gateway somehow to play the Ruckus game. That means, as Jussi has said before, there are a few access points on the hallways. That's fine for basic coverage. Some people suffer more than others, but it's fine in general, and it's a cheap approach to do that. And then you add the door locks, and in normal cases, this is fine, because the door locks normally have the IoT radio on the outside of the door, so they share the common area of the hallway, and they can connect to the access point, everything is fine. Typically, these are operated by Zigbee technology, and that means that you properly connect, 4 to 8 doors per AP. Well, that's a rough number, right? It's depending on the situation, on the RF situation, but 6 to 8, maybe up to 10 is the maximum number. This is what we see. Now the hotel is saying, okay, let's go for this panic button solution. You want to add value to the network you're already operating. Yes, you can do that, and they will probably connect fine to the access points. They're also able to maybe to provide BLE connectivity. But what you not get is accuracy. So finding out where the alarm comes from is not possible with that approach. That means you can only say, okay, there's an alert, and I get, I don't know, accuracy of 6, 8, 10 rooms. The problem is somewhere there. That's not enough for that kind of security-related solution. Therefore, you go with your beacons, with your gateways, you go into the rooms. We have to expand that network. And normally you go for, I don't know, every 3 or 2 rooms, something like that. You get an AP, a sensor, a gateway, a beacon. And then you get that room level accuracy where you can send help if something happens. Now think about, they want to have smart rooms in the end, like adding thermostats or adding sensors for automatic lighting when I enter the room and everything. And then it's getting more complicated because probably if you have these APs every 2 or 3 rooms, you can onboard these thermostats and everything will look fine in the first place. But then communication is coming up. You have 2.4 gigahertz. Everything is watching Netflix. All the thermostats are going online, and then they will see that if the noise raises, that these cheap devices will fall off the network one after another over time, and that's not desirable. That means for such a smart room solution, then you would go and place access points in every room, like a wall plate access point providing connectivity into the room and possibilities for connecting IoT as well. And if you do that in 3 steps, always pulling new cables, adding more costs and problems, this is a problem. You cannot do that. So planning ahead, thinking about the requirements of tomorrow is more important than ever. And this is also about, of course, sensor to AP to gateway density. And this is not comparable to Wi-Fi. That means with Wi-Fi, I know, I've seen 300 clients on a Ruckus AP. It was okay for that requirement at that time. Normally we see with IoT gateways that we have 10 devices per gateway, at least spoken about Zigbee at that point of time. So that's an average number. I think we support up to 32, which is possible. But yeah, normally you don't have this density, that amount of devices in your in these use cases. Security is another very important part, and IoT can be very unsecure. So maybe you don't have encryption at all. Using a Zigbee sniffer can easily get you in a position to take out the data and do something with that. But of course, there are possibilities. You can use Zigbee 3.0, which introduces radio encryption. You can have proprietary protocols from these door lock vendors, for example, which add another layer of security. Then separating IoT traffic from anything else is quite a good move. And it's very easy to do with VLAN separation. Segmentation of traffic is always helpful. That means all the Wi-Fi stuff, the management stuff of the access points going in these VLANs, but the IoT traffic is going to that VLAN, which is only routed over there. And another thing is, and that's a little bit of the discussion here, that's pros and cons. Maybe it's helpful to aggregate the upstream traffic somehow. Because when you have tens of thousands of gateways in your properties, maybe you don't want every single access point and every single gateway to communicate with your back-end servers, with your cloud systems. You're creating a kind of, I don't know, like a mesh architecture where everything is speaking to someone. And of course, this is I don't know, saving maybe costs because the access point can do that. Of course, it can do that, but maybe adding another point of security, like the device is encrypted, communicating encrypted to the gateway. Then the gateway is communicating to an aggregation point, like a controller, via a TLS tunnel. And then we have this defined aggregation point, which is connected to a firewall for traffic inspection, maybe which is, you have a single point of interaction via APIs. That can be helpful, especially when you want to scale. And then, of course, monitoring. I've talked about these use cases where you want to know what the device is doing, which only communicates every now and then. But it's all about management of the gateways, how you onboard your devices to the gateways. When you get alerts that you have to change some batteries somewhere, if traffic is coming, if the right amount of traffic is coming, if the connection quality, the RF quality is good or as it should be. And of course, then it's all about reducing costs at the end again, right? So you have to get some insights to make that sure. Yeah, so, and I think there are a lot of more things to consider, of course, but I think that these are the main three points to mention here. Okay, I have a whole use case where we can talk through everything again, but we've already done this for NH Hotel instead of Royal Parks, which is the Ruckus use case. So I let it in the slides, and you can have a look later on if you like to do that. And with that, 2 minutes early. Thank you very much. I can recommend that you can win IoT-enabled access point this evening. So come join us in the raffle, and thank you and have a good day.